Now that you've got an overdraw under control, it's time to bubble up a bit and start looking at the CPU portion of the rendering pipeline. In order to draw something on the screen, Android generally needs to convert all that high-level XML into something that the GPU can accept and use to render to the screen. This is done with the help of an internal Android object called a display list. A display list basically holds all the information needed to render a view on the GPU. It contains a list of any GPU resident assets that might be needed, as well as a list of commands to execute with OpenGL in order to render it. The first time a view needs to be rendered, a display list will be created for it, and when we need to render that view to the screen, we execute that display list by submitting its drawing commands to the GPU. If we want to render that view in the future again, like if its position changed on screen, we simply need to execute that display list again. However, in the future, if some visual part of this view changes, the previous display list may no longer be valid. As such, we'll need to recreate the display list and then re-execute them to update the screen. Now, remember this, anytime the drawing content of your view changes, it will repeat the process of recreating the display list and then re-executing it to get it to the screen. The performance of these operations varies depending on how complex your view actually is. And depending on the type of visual change, there's other impact on the rendering pipeline as well. For example, let's say that a text box suddenly doubles in size, causing the parent container to reposition other sibling views before updating its own size. In this case, we've updated one view and it cascaded to other work that needed to be done. These types of visual changes require additional stages of the rendering pipeline to occur. See, when the sizing of your view changes, the measure phase will be kicked off, and it will walk through your view hierarchy, asking each view what its new sizes are. Basically, this happens anytime you change the size of a view, for example, padding, drawable size, set text, scale, width, height, etc. And if you change the position of things, or call request layout, or a view group repositions its children, then the layout phase will kick off, traversing the hierarchy and determining where all the new locations of the object should actually be on the screen. Now, the Android renderer system is really efficient at handling the record and execute phases of the pipeline. And unless you're doing something crazy with custom views, or suddenly a ton of views are getting drawn at once, these shouldn't account for much of your frame time. Measure and layout phases are also pretty performant, but are more prone to run into performance problems when your view hierarchy gets out of hand. See, the time taken to execute these functions is proportional to the amount of nodes in your view hierarchy that have to be processed as a result. The more views that this system has to touch, the longer it takes, and some views may have worse overhead than others. And the number one overhead for this operation is having a lot of redundant, unneeded views lying around in your view hierarchy. See, these views don't visually contribute to the final scene and generally end up just eating up your performance when a measure or layout phase actually kicks off. Thankfully, there's a great tool available to help you find and fix these rogue views called Hierarchy Viewer. Let's take a look.